Every second Earth is under attack. Invisible bullets, streams of charged particles from the sun, slam into our planet at millions of kilometers per hour. If they reached the ground, they would strip away our atmosphere, fry our technology, and make life almost impossible. So, why are we still here? Because Earth has a secret weapon, an invisible shield that has protected us for billions of years. This is the story of Earth's magnetic field. Earth is, in a sense, a giant magnet. Deep below our feet lies the outer core, a swirling ocean of molten iron and nickel. As this liquid metal moves, it generates electric currents, and moving electricity creates magnetism. This process, known as the geodynamo, is what powers our global magnetic field. It's been running like a cosmic engine for billions of years, and it extends tens of thousands of kilometers into space. When the solar wind collides with this field, it carves out a protective bubble called the magnetosphere. On the side facing the sun, the bubble is squashed, and on the far side, it stretches into a long magnetic tail that reaches beyond the moon's orbit. This giant magnetic cocoon is our first line of defense against space radiation, a force field standing between us and the harshness of space. To see why this shield matters, just look at Mars. Billions of years ago, Mars likely had rivers, lakes, maybe even oceans. But Mars lost its global magnetic field early in its history. Without protection, the solar wind slowly stripped away much of its atmosphere. Today, Mars is cold, dry, and exposed to radiation. Earth might have suffered the same fate, if not for its magnetic shield. Not every planet is so lucky. Mercury has only a tiny, weak magnetic field, offering little protection. Venus has none at all, and its atmosphere has been battered by the sun for billions of years. Then there's Jupiter, a planet with a magnetic field so powerful it would make Earth's look like a toy magnet. Its field is 20,000 times stronger than ours, and it traps radiation so intense that it would destroy an unshielded spacecraft. Compared to our neighbors, Earth's field is a perfect balance. Strong enough to protect life, but not so extreme that it becomes deadly. This raises a big question. Could life survive on a planet without a magnetic shield? Maybe if the planet had an incredibly thick atmosphere, or if life adapted deep underground or underwater. But here on Earth, our atmosphere and our magnetic field work together. One keeps the air we breathe in place. The other keeps it safe from being stripped away. Without that team effort, we might not be here at all. But the magnetic field doesn't just block cosmic radiation. It also traps it, redirects it, and sometimes even turns it into something beautiful. To see that, we have to look at what happens when the shield is pushed to its limits. When charged particles from the sun try to breach Earth's defenses, many are deflected, but some get caught in the trap. Spiraling around Earth's magnetic lines, they form zones of radiation called the Van Allen belts. Discovered in 1958 by the very first US satellite, Explorer 1. For us, on the ground, this is great news. The belts keep much of that radiation locked far above the surface. But for astronauts and satellites, these regions are dangerous. Engineers have to design spacecraft that either avoid the belts or are heavily shielded to survive them. Not all of those particles stay trapped. Some get funneled down along magnetic field lines near Earth's poles. When they crash into oxygen and nitrogen atoms high in the atmosphere, they release energy as light. That's the northern and southern lights, auroras. What looks like a peaceful sky show is really Earth's defense system in action, transforming violent solar radiation into waves of green, pink, and purple fire across the sky. But Earth's shield isn't perfect. During powerful solar storms, Massive bursts of energy from the sun can slam into our magnetosphere, bending and shaking it. These events, called geomagnetic storms, can overload our modern technology. Satellites can be knocked offline. GPS can be scrambled. Airlines sometimes reroute flights to avoid exposing passengers and crews to extra radiation. In 1989, one of these storms caused a 9-hour blackout across the entire Canadian province of Quebec. Millions of people lost power, all because charged particles from the sun induced electrical currents in the grid, tripping transformers and knocking systems offline. And it could be worse. Back in 1859, a solar storm known as the Carrington event set telegraph wires sparking across the world. Some even caught fire. If a storm of that magnitude struck today, the damage would be catastrophic. Power grids could fail, satellites could fry, and our connected world could go dark. Imagine waking up tomorrow with no internet, no GPS, and no power for days, maybe weeks. Air travel halted, banking systems frozen, communication satellites disabled. This is the nightmare scenario scientists warn about. It's why we now have satellites like DSCOVR and SOHO orbiting between Earth and the Sun, giving us precious minutes of warning when solar storms head our way. In the space age, knowing what's coming can mean the difference between resilience and chaos. Adding to the drama, Earth's field itself is not constant. It drifts, it weakens, and every so often, it flips direction completely. North becomes south, and south becomes north. The last time this happened was about 780,000 years ago. How do we know? Volcanic rocks preserve tiny records of the magnetic field frozen in place as they cool, letting scientists read Earth's magnetic history like pages in a book. If the field weakens significantly, more radiation will reach satellites, astronauts, and even the surface. But here's a thought. Could we one day build our own magnetic shield? Some scientists have proposed orbiting superconducting coils or plasma shields to protect spacecraft, even entire planets. It sounds like science fiction, but then again, so does the idea of an invisible field protecting us right now. So the magnetic field doesn't just block space radiation. It traps it, it shapes it, and it sometimes fails in spectacular ways. But what happens when humans leave Earth behind? To live on the Moon or Mars, worlds without protective shields of their own. That's where this story really hits the future. Even in our daily lives, the magnetic field quietly shapes the world. Compasses point north because of it, guiding explorers for centuries. Many animals, from birds to sea turtles, navigate using Earth's magnetic cues, and even bacteria use tiny magnetic crystals inside their bodies to orient themselves. Life on Earth has grown up under this shield, and many creatures are literally wired to depend on it. But when humans leave Earth, things change. The Moon has no magnetic field. Mars lost its shield long ago. That means astronauts on these worlds are exposed to far more radiation than we ever experience here. Long-term missions on Mars or the Moon won't just need oxygen and water. They'll need protection from space itself. NASA and other space agencies are already studying solutions. Thick, underground habitats, spacecraft that generate mini magnetospheres, and even artificial radiation shields made of plasma or superconducting magnets. If we want to become a spacefaring species, we may need to build the kind of shield Earth already provides for free. Could Earth's magnetic field ever disappear entirely? The good news is, not anytime soon. As long as the molten outer core keeps churning, the dynamo keeps running. Even during magnetic reversals, when the field weakens, it never fully vanishes. But thinking about a world without it reminds us just how fragile our shield is, and how dependent we are on forces deep inside our planet. Earth's magnetic field is one of the unsung heroes of our survival. It keeps our atmosphere in place, shields us from deadly radiation, and even turns violent solar storms into dancing curtains of light. Without it, our planet might look a lot more like Mars. But with it, Earth remains a rare safe haven in the solar system. So the next time you see the northern lights, remember, you're watching our planet's shield at work. The invisible force that makes life on Earth possible. Thanks for sticking with me to the end. If you learned something new today, give this video a like. It really helps. And if you want more deep dives into the world around us, hit subscribe so you don't miss the next one. Until then, thanks for watching, and I'll see you in the next video.